Okay, I hope everyone can see the screen now. Whiteboard as well.
Can anyone see the screen? If you can see the screen, just unmute yourself.
Yes, I can see. I can see the screen.
Yes.
Madam Mekani, are you there? You've been quiet. I don't know if
Yes,
you're
sir. Yes, sir. I'm there.
okay.
I can see the screen too.
Okay, awesome. So today we are learning about AWS VPC. Okay, so whatever we have talked earlier, right, about the networking, this whole thing is the same thing but on a cloud. Okay, so basically, as I said earlier, also we have a router, right, like a device that connects two different networks together, like a public and a private network, correct? So the same concepts applies everywhere, by the way, everywhere, like on-prem devices, on cloud devices, everywhere the concept is kind of same. You just have to remember like what is a private network, what is a public network, and we will be using that private and public concept everywhere. For security reasons also, I'll talk about that more, like where we can implement those things. But usually if in AWS, right, the networking, like the network that we create, okay, that is called VPC, virtual private cloud. Okay, so don't get confused with the names. The names are just there so that you can like differentiate between services. But private cloud, AWS virtual private cloud means, like, just remember, this is the networking part of AWS, and without network, no resource can work, right? So just as like your mobile phones, your devices, your PCs, and anything, if it is not connected to the router, they cannot access anything because they are cut off from the internet, correct? So same thing applies to this VPC. Without VPC, no AWS resources or devices can work. So that is why it is called the backbone of AWS, right? Without this, nothing will work. So today we'll learn like what is VPC, what are the things that we get inside VPC, or to get like we get into VPC, and a little bit about networking, like what basic networking is, right? So it's like some few things related to networking that will help you to create and work with these VPCs. So we'll be exploring those things. So let's just understand first of all what is VPC. Okay, so basically VPC is logically isolated virtual network. Okay, why we are calling it as logically, right? Why it is a logical network. So remember, in our homes, right, we have the physical routers. We have the routers available physically in our home, right? And with those routers, we connect our devices, correct? The problem is when we are talking about cloud, in cloud, we don't have those physical devices available to us. Everything is logical there. Like it's running behind the scenes, but we don't get the access. We just see the, we can just access through software, right? That's why it is logical. We don't have any physical devices that we can interact with. So everything is logical on AWS. So we have all the services, we can provision those services, but it's all logical because we cannot interact with the devices directly, right? There's no physical interaction between the devices. It's all logically being done. So that's why it is called a logically isolated virtual network, because it's totally isolated. You do not get any physical devices, and we can set up everything. By the way, the networking, like even if we don't get a physical device, we can still set up the whole network logically. That is totally possible. Okay, so in networks, basically what we have in networks, we have few things that are very much required for the network to work and talk to each other. Because when we are creating a network, right, usually what we are doing is, so internet, like let me just give you a brief on what is internet. Internet is all the devices or any devices, right? Like for example, we have 4 devices and they are connected to the same network. That means they can talk to each other because they're on the same network. As I said, if the devices are on the same network, they can talk to each other. Okay, that's why in your private network, they can talk to each other, but on a public network, they will require a public IP. Okay, so the thing is, your internet is a is a group of devices talking to each other continuously. That is internet. So basically, like for example, this is your network. You have a router, and you have another network on like somewhere else in the world, right? And this is also on its own private network. And the problem is, if you remember, private networks cannot interact like you, or like if you're coming from the internet, you cannot interact with the private network because that is private. That's the whole concept. It is private. It is not supposed to be interacted with other devices until and unless there's a bridge that can help them to interact, and that is our router. Okay, so router can connect private as well as your public networks, right? It can interact with them and then together. So usually what we can do is here also there will be a router. This router will connect to this and this will connect to this. So what will happen is now this public network is being like shared via this private, this private network is being shared via this public IP of this router and vice versa from here, and then they can talk to each other. Like this on internet, we have multiple routers, switches, and like different kind of devices talking to each other continuously. Obviously with the public IP. Remember, only public IPs can talk to internet, right? Without this, there's no means to like connect to the internet. So they're all talking via the public IP addresses. So the thing is like it's all group of devices talking to each other continuously via the public IPs. Okay. So that is what internet is. And in VPC also, what we have is we have these IP ranges because if you remember, if you have one public IP, if you have it, right, that public IP cannot be used by anyone else because that's a unique address. So if my device is using a public IP, that means that is unique to me only, and that is globally available to me. No one can have it. That's why there is like public IP ranges. So your ISP or your internet provider will have a different IP that he will be giving to you, right? My internet provider is different, so they will have their own IP that I'm using. So like this, everyone can have like different IP providers or different ISPs. So they'll be getting like different IP addresses. Okay, so basically in AWS also, what we can do is we can define our own IP ranges. We can create public and private networks here, just like the real world. We can do that. We can have our subnets. I will explain what a subnet is, and this is really important. So we will we will understand it more, we can say thoroughly, because this is very much required to create networks and understand networks. And then there is route tables. So understand route tables are, it's like, for example, as I was giving you this example, right? So this router is able to reach to this router. How? Because it has a route table built to it now. So let me explain it more easily so that it's understandable. So let's give you a very simple example. Okay. So this is my device. Let's make like this is my mobile phone. It is connected to a router. Okay. Because same thing, without a router, I don't have a public IP, and without a public IP, I cannot talk to internet. Okay. So what I did is I asked for google.com. The problem is google.com is available on the internet, right? It's not on the private network. So what happens is this router does not know where google.com exists. Okay. So for example, this is the server of google.com. This is the server of google.com. Now a router does not know where the google.com exists. So when the request reaches to router, it goes to a DNS. So DNS is like domain name servers. Like there are multiple servers that change IP to names and name to IPs. Okay. So basically what happens is this router goes to this DNS and asks the DNS like where can I find google.com? It's like a registry, like we have the phone books where we have all the phone numbers, like a phone directory. We have all the phone numbers there stored. Okay. So DNS is kind of like that only. It's the address book of internet. So whatever address you want to find, for example, google.com, yahoo.com, amazon.com, whatever that is, DNS servers are the one that holds those addresses. So whenever a router or whenever a network wants to reach to a particular address, right, they have to go through the DNS. They ask the DNS. It's like the registry book. And then the DNS will forward it to the google.com server. Okay. So what happens is when it reaches to google.com, then obviously google.com replies back, and this reply goes to router. Now the problem is router is a smart device. Okay. So it's like the human being. For example, you come to my house The first time it will be problematic for you to find my house, right? But once you reach my house, you will remember the address, because what you did, you created a route into your mind. So what happens is, once you create a route, it's like a registry into your mind. Now you know how to reach me. So this is called a route table. So a router creates these route tables. So whenever a query comes in and it has the route table created for that particular query, it will directly go there. It does not require any DNS or anything. It will just go there directly to google.com. So now usually what happens is, whenever you buy a new device, you open google.com or any website, it will open slowly first, but the next time it will open fast. For example, let me just demonstrate something. For example, let me open this thing in incognito and I go to my website, Planet Devs. Let's go there. It was fast here because I've already opened it. What website to open? No, I have gone through a lot of websites. Let me see Edge. I think Edge should take time. Okay, so if I open, okay, so this is my website. If I open this, here, right, it opened. Okay, so now what happened? It took a little bit of time, but what if I again open that same thing? See, this was fast. So there's a millisecond of gap usually, but that is what happens. So basically, like the devices are like smart now, right? So what happened is, the first time router go to the DNS server, and then the DNS server pointed to that, hey, this is the website, right? The next time the router does not have to go to the DNS server, it already knows the address, so it will directly reach here. So until and unless it was not able to find anything on the address that it requires, right? Then only it will go and ask the DNS, like, hey, where can I find this? Like, I'm not able to find it. So if the address has changed, DNS will point it. So that is what route tables are. So router creates tables that that gives the path to the router, that like you can use this route to reach to that particular destination. So that is what route tables are, and this is very much required for the networks when you set up, because without it, your router will not work properly. It won't be able to reach any network or any destination. Okay, and then you have gateways. So gateways are a very simple concept. Remember, gateway is something, it's like your door, your gate. So what happens is, for example, you have a house, and this is your door, okay, your gateway into your house. So what happens is, for example, if a person wants to go out, they will have to use this gate to go out, right, and come in. So this particular point where you come in and go out is called a gateway. And there are multiple gateways in internet. So sorry, in VPC. So the most famous ones are two. So one is called IGW, that is Internet Gateway. As the name suggests, if you have an internet gateway, only then you can connect to the internet. Without IGW, you cannot connect to the internet. Okay, and then there is one called NAT gateway. NAT I will explain when we go there. But remember, there is this gateway, and this is really important. That is called IGW, Internet Gateway. And in your AWS, if you don't have Internet Gateway, that means you will never be able to connect to the internet. And that is very much required, because you want to download the packages, you want to do a lot of stuff with the internet, right? You will require, if for example you want to host your website, you will have to have the internet gateway access. Otherwise, you won't be able to like go out and connect to the internet. So that is what gateways are. Okay. So mirrors on-premise data centers. So basically, these networks are created into data centers. Okay, and the networks are similar to on-premise data centers. So what is on-premise data center? So basically, what happens is, big companies, right? They have their own servers into their office. Like, they don't rely on cloud. They have their own servers. Usually earlier, every company needs to have it, because otherwise they cannot host anything. Okay. So the main, like how the data center is created on premise, right? or it is set up, the same kind of networking can be done on AWS VPC. But the only difference is because in data centers in on-premise, you have the physical servers on with you that you go and configure. And let me tell you that on-premise data center configuration is really hard. It's not that easy. But when it comes to AWS VPCs, right? AWS has already set up everything for you. You just have to configure and you just have to tell them how you want your network to be designed. And that's it. They will do it for you. You just have to define the properties. Like, for example, this is the kind of IP address that I need. I will be requiring to create a ITW. I will need a NAT gateway. Like, you just define them what you need and they will set it up for you. So it's that easy. But in on-premise data centers, you will have to do everything from scratch, and that is really not an easy thing to do. But AWS VPC can replicate the whole thing, that you can do it on-premise. So that is what it means. Like, it can mirror. So whatever you can create on on-premise, you can create that on AWS also. Logically, but you can create. And then you have full network control, because the network is like, you are not connecting to the physical device, but you are logically creating all those things. Okay. So the thing is, whatever you are creating, remember one thing, whatever you create as a user, you will have full access to it. AWS will not have access to it. But whatever is created by AWS, then as a user, as a customer, you won't get the access to it. So anything that is created by AWS will be AWS managed, and anything that you are created will be called as customer managed resources. Okay. So in VPCs, you will have full control. And I'll give you the limitations also. Like, there are few limitations also in VPC, because obviously you are not the owner of the whole devices that they are running. Okay. So every user will have some limitations built into it. So I'll tell you about those limitations as well. Okay. So let's start with the basic thing first, like what we get into the VPC and what are those. Okay. So the main thing in networking, it is called subnets. Okay. So what happens is, what is subnet? So basically, network or net, right, is a full network. For example, you have, let me remove this. Okay. So for example, I have a network of 10.0.0.0/16. I will explain this thing, like what is that. But remember, this is a very big network. So basically, in this network, you can have 65,536 devices. Like, all these devices will be inside the same network. You can have this many devices in this network, which says /16. Okay. So what happens is, this is a lot of devices. I don't require this much devices, right? Like, company should be very big to handle this much devices. So what I do is, I create, like, this network is too big for me, right? And these many devices can talk to each other. The problem is, I don't want these many devices to talk to each other. For example, I have my office, right? And I have few departments in my office. Like, this is the developer department, this is my HR department, this is my finance department, or this is something else, like a head, anything, head department, right? Head office or something. So yeah, head office. So what happens is, I don't want all these devices to talk to each other, because the problem is, if the more the devices can talk to each other, the more there will be vulnerabilities. Okay. So the problem is, for example, if anyone hacked into this dev department, they get access to everyone, like every network or every devices into my network, right? So this is a very big flaw for me. And because my network can hold this many devices, that means those devices can talk to each other. So usually what happens is, we divide the whole network. This is a very big network. We divide it into smaller networks. So for example, I create 10.0.0.1/24. And here only 256 devices can talk to each other. That means in a single network, there can be only 256 devices. And if you remember, devices in the same network only can talk to each other. So for example, dev will have 256 devices, HR will have 256 devices, my finance department will have 256, and HO department will have like 256 devices. So what happens is, my full network is there only, but what I've done is, I've divided the network into smaller parts. So the benefit of this is, this in this smaller network, I can only have 256 devices. And this 256 devices here will not be able to talk to each other because they are different networks now. So it's like taking a bigger network and dividing it into smaller networks so that I can create isolations and I can create multiple small networks with the big network. And that is called subnetting. That is subdivisions of the VPC's IP range. I'm subdividing my bigger IP into smaller IP chunks so that I can divide and isolate different departments or different IPs between each other. Is that clear? This subnet thing. So we are taking a big network and dividing into smaller networks. And just remember this concept. This concept is applied everywhere. Only same networks or anything within the same network, only those devices can talk to each other. Anything that is outside their own network, they cannot talk to each other. I'll be explaining this network thing, and this is what is like dividing the network, and this is what tells you like how much devices a network can have. But just remember, different networks cannot talk to each other until and unless there is something like a router or something that can translate and create routes. Okay. Until then, networks cannot talk to each other. So each network, each different network is isolated to each other. So they cannot talk to each other. And that is what we want in networking. We want isolations. Okay. And that is what we create subnets. We divide a bigger network into smaller chunks. Then we have internet gateway. As I said, internet gateway is a gateway which attaches your VPC, right, to the internet. So without an internet gateway, your VPC or your internal network, right? Your VPC is an internal network. Your VPC cannot talk to internet gateway. Sorry, you cannot talk to internet. So without an internet gateway, your VPC is nothing. Like it won't be able to connect to internet. So internet gateway is required. So it's like you have a big home and that is your VPC, right? You have different subnets. Those are your rooms. So one person within this room cannot talk to this person in this room. Like that is what happens, right? If you are inside a room, you divide. So for example, okay, that's a really good example. Let me give you the example. So for example, you're creating a very big house. Okay. You're creating a big house. So usually it's not like you just create the house and there is no walls and nothing. Like the house is never empty, right? It always have walls, right? You will have walls. Different sections divided. For example, this is the bedroom, this is your kitchen, maybe is the kids' bedroom. Like this, you have guest room, right? Like whatnot, correct? So you all are within the same house, but still these things are divided, right? These things are divided into like multiple rooms. So, okay, can anyone answer me like why do we do that inside a single house? Why do we create rooms, different rooms? Why don't we leave the house as it is, like without creating any rooms? A single big room.
Then everyone will be able to communicate with everyone at the same time.
Communicate and there will be no privacy.
Yes.
There will be no isolations, right? So usually in networks also we do that. So we do like this is the house is same, right? We just dividing the house into smaller parts, correct? So that we can have privacy, we can have some isolation, correct? We don't want like everything to talk to each other, or they just like come in without permission. We don't want those things, right? So that is how the network also works. When we have a big network, we don't want all the devices to talk to each other, because if there is no isolation, they can talk to each other freely, right? There's nothing stopping them. So basically, like this, we create smaller networks, and those are called subnets in VPCs. Okay. And the thing is, as I said, internet is your world, like your outside world, right? This is your outside world. This is all private. Inside, this is all private. The problem is without a gateway, for example, I built the house, I did not create a gate. You're inside. So will you be able to go out without a door?
So please come again.
Yeah, I'm saying like if you create a house, right? You created all the rooms and everything. The problem is you forgot to create a gate or a door. Will you be able to go out, or anyone within this house? No, right? because without a door, you will not be able to go out. Correct? You will require a door or something. And this door is your gateway to the world. And that is what IGW is. So without IGW, you cannot connect to the internet. Remember, this part is very important. Without IGW, IGW is the gateway. Without IGW, you cannot connect to the internet, or your VPC cannot connect to the internet. So if there is no IGW, sorry, VPC, not G. If there is no IGW, then that means there is no internet. So your VPC will not be able to connect to the internet without an IGW. And IGW is the single point of contact that can help you to connect to the internet. So if you don't have an IGW, there will be no internet connections to your VPC. Is that clear?
Yes, sir.
Okay. So like that is why I said like IGW is a very important thing to know. Okay. And gateways are the same thing. Anything that allows inbound and outbound connection to be like going in and out, that is the gateway. They will require something to go in and like come in and go out, right? So that is the gateway. So there is one more gateway that is called a NAT gateway. And this NAT gateway is also very important. It's important where, let me tell you, like you are using it in your day-to-day basis, by the way. So for example, let me create a network. For example, I have this device, right? And I have one more device. So for example, this device is has a public IP. Okay, I have a public IP. So like your mobile phone, if it is running on the SIM, right? You have a SIM card inside your mobile phones. So if you have data on your SIM, right? You like if you have the data, you won't require any router, will you? Like if you have data into your SIM, right? You won't require any router. You don't require any Wi-Fi. You can directly connect to the internet. Am I right? You can do that,
Yes.
Yes, sir.
right? That means you have a public network. You are not required to like you don't require any assistance to help you to connect to the internet, right? You already have whatever you need. Your ISP is handling that router request and everything, right? So that means your mobile is on the public network already. It can directly go to the IGW or connect to the IGW, correct? And with the IGW, they can, let me, one second, it's too big. Here, okay. So it can use the IGW directly. IGW, that is the internet gateway, right? It can use it directly. And using the IGW, they can go to the internet, right? It's the internet they can access, correct? The problem is, what if you don't have a SIM? For example, your mobile, your laptops. So your laptops does not support SIMs, correct? You cannot put in a SIM and then you can connect directly. You cannot do that, correct? So in that case, what do you have? You have to connect to a Wi-Fi, right? You cannot have SIM everywhere. So you want to connect to a Wi-Fi. The problem is, because you cannot directly connect, so by default you will be inside a private network, correct? This will be a private network. This is a private network because there's no internet connectivity here, and there is no means to connect to the IGW as well, right? So here what we do is we require a router, we use a router, correct? So that uses a protocol, router uses a protocol that is called NAT. NAT means network address translation. I'll just tell you what that is. So basically what happens is the request that is coming into the NAT or your router, basically, it is coming via the private IP. Remember this part I already showed you as well. This thing is coming, one second guys. Okay, sorry. So this request, right? Any request, for example, this laptop wants to access google.com, right? This laptop has a private IP, correct? So this private IP will go to this NAT, that is your network address translation, and that is your router. Okay. So what happens is, as I said earlier also, the data travels in packets, small packets, right? So the packet will come to your router, and this packet will have a label on it, and this label will have the private IP onto it. For example, the private IP is this, right? 121 dot something something something, right? It's like 1.1 something. This is the private IP. The problem with private IP is we cannot use private IP to connect to the internet. Is that, if you guys remember, I told you about this. Private IPs cannot access the internet. That's why they are private, correct? So to access the internet, we require a public IP. You guys remember? I told you about that. Like that is what you're paying for. You require, like, to use the internet, you require a public IP, right? And the problem is public IP is given to you by the ISP, right? The internet provider. So the thing is, you will require something. You will require a gateway. Okay. So what happens is this router, it uses a protocol called NAT, network address translation. So what it does is, because this router has the public IP, this thing is connected to the IDW. NAT is connected to the IDW. Remember, this NAT is connecting, not your laptop. Your laptop is in private space. This thing is not connecting directly to the IDW. This thing is connecting to the NAT or your router in common terms. And this router is connected to the IDW. That is your internet gateway. So router can access the internet. Your laptops or your devices cannot. Okay, without a router. So if I remove the router, if I close the router, this will not be able to connect to the internet anymore. Okay. So what the router does is, because router has a public IP, right? So what router does is, router puts another label on top of this label with the public IP. And now this packet is forwarded to the IDW, and through the IDW, it reaches to the internet. So the internet sees the public IP label that is put up by the router. It replies back to the router. The request goes back again here. And what the router will do is, the router will remove its own label, and within this, like below this label, you will have the private IP. And by looking at the private IP and by looking at the address, because router maintains an address book, right? It maintains the routes. Okay, with the routes, it will know that, okay, this particular device has this private IP, and this request was like done by this particular laptop, and then it will forward that request here. So NAT is kind of a proxy in between. So it is translating the addresses from private to public and public to private. Is that clear? That is what NAT is. Network address translation. So it is translating private IP to public IP and public IP to private IP. Is this clear? Or any doubts you guys can ask? Like, this can get confusing, but if you understand, it will not be that problematic.
So please, you said the NAT transforms what to what, please?
Okay, so basically your laptop has a private IP, correct? And if you remember, as I said, private IPs cannot talk to the internet directly. They will require a public IP, right? It's like that particular thing is required. It's a must. You should have a public IP to connect to the internet. Is that, like, you guys remember that? I told you about that in the previous section. Yeah. So without public IP, you cannot connect. And we have a router for that, right? Router translates our private IP to public IP, correct? So router does that with a protocol. It's called a protocol. It's called NAT, network address translation. So it translates. It's like a translator in between. So it translates the private IP to public IP and public IP to private IP. Because what it is doing is, for example, it is taking the package. On the package, you have the sender's address, correct? That's how you know, like, who is sending that package to me, correct? And you remember that sender's address is not known to you. For example, your home address. I don't know that. No one knows it, right? But I know DTDC, or a very big company, like any big delivery companies, right? They are known, correct? So what they do is they take your package. So by default, your package does not get delivered directly to the destination. It always reaches a warehouse where they put on their label. Understanding? Like that is, I think everyone would have done a courier or something, right? Like at some point of time. So usually what happens is there's always a courier company in between, right? That will put their label and then they ship it. Okay. And your router is kind of like that. It will take your packet, it will put its own label because it can access the internet. It will put its own label on your label, right? It is translating public to private and private to public. Okay. So when the packet goes out to the internet, it will go out with the public IP that the router has given. Okay. So the router will put its own public IP there. It will go to the internet. Internet will reply back to the router. Then the router will remove the public IP label. And then within like below that label, there will be the private IP, right? Then it will check who has this private IP. And by checking that, it will know, okay, this particular device has this private IP. And this is the device that requested me to go to google.com or to get this request. And then it will forward that packet to the particular device with the private IP. Is that clear now? That is called NAT, private to public and public to private. Like it's like a translation.
Yes,
Is that clear?
thank you.
Yes,
Okay.
sir.
Okay. That is what a NAT
Yes.
is. Network address translation. We are translating the address from private to public and public to private. Okay. So these are the two important things that is required. And this is what we will be using extensively to protect our network. So if this is clear, a lot of, like you can say, your basics are kind of clear if you understand this thing. Okay, now we have something called VPC endpoints. So endpoints is kind of different. So here we are using gateways to connect, right? Endpoints are like VPNs. Let me explain you what a VPN is first of all. Then you will be able to understand the endpoint. Okay. So usually what is happening is we are connecting via the public IP or we are using a NAT, right? With like private to public and whatnot. But with endpoints, like when we are talking about endpoints, we are using a different set of network. Like it is the same thing, it is working on the same concept. But the only thing that is changing is now you're not creating all those NAT and public IPs and IDWs. You don't need that. Now what you're doing is you have one network. For example, I have this router, right? And I have this router, a different router. Now, without going to the IDW, without using IDW or anything, what I'm doing is I'm using something called an endpoint. Endpoint is like a proxy, a tunnel. It's like a tunnel. So, for example, this device, this is an EC2 instance, and this wants to talk to a different EC2 instance, for example, right? So what I can do is I can create a tunnel between them. I can create a private network between them. And this whole network will be created by AWS in the backend. You don't have to do anything. You don't have to set up anything. You just create an endpoint and then it will create a private connection between them. So this private IP can talk to this private IP directly. Like you can talk privately. You don't even need a public IP to connect. So anyone have used VPN? Anyone? If someone has used VPN.
Yes.
Yes, sir.
So do you understand
Yes,
how the
sir.
VPN works? Like what is happening behind the scenes?
They don't. They just use it.
No,
Okay,
no,
they
I
just
don't.
use it.
Just
Okay. Okay.
exactly.
No worries.
Honestly, we use it, but we don't even
Huh?
understand about what it. I say honestly, I've used it, but without thinking what it's all about. I just use
Okay.
it. Mm.
Okay. So let me explain. Okay. Endpoints are like VPNs only. Like it's a virtual VPN, you can say. So what happens is basically VPNs are used for a specific purpose, right? Let me tell you the purpose and then I'll explain the process behind it. Okay. So what happens is basically AWS, I'm not getting into AWS right now. I'll just explain the basic VPN and then I'll get into the AWS thing. Okay. So basically what happens is whenever you're using VPNs, let's take the office as an example, right? You have an office and you're working from home. Like this is you are working from home, right? But this office has its own network, right? There's a network, for example, this network 1.1.1. And the devices within this office There are multiple devices within this office, and these devices are configured to connect only and to reply only to this IP. So if you are not using, or if you're not into this IP, or not getting this IP, or not using this IP, this office IP, right? You cannot access the devices. This devices are configured like that. But the problem is you're working from home and your IP is different. For example, your IP is 192.168.1.1. So will you be able to connect to your office with this IP? Because your IP is restricted, your office is restricted to only connect with this IP. You won't be able to connect. Am I right?
Yes, sir.
So what can we do in this time? Like, either there are two options. Either you go to your office and log in from here using their own Wi-Fi network, right? Then you will get this IP, right? You will within their own IP and then you can work. But remember one thing, office IPs are not publicly shared. They are really sensitive. So they are private IPs. They are private, right? They only work within the premises of your office, and outside of it, you cannot access. So offices are created like that with the private IPs, right? The only problem is because you're working from your home, you cannot connect because it is private, right? So we require something. So either we go to the office and connect to the network, only then we can access, or we use a VPN. So what a VPN does is, these offices, they create a service called VPN, a virtual private network. Okay. So what happens is there are routers that are creating a tunnel. Tunnel means now you can talk uh, via private IPs. You can talk via private IPs. But the problem is when you connect to this VPN, to their own VPN, right? Your IP will change. You will be logically not, remember, understand, you're not like physically connecting, you're logically connecting to the IP of this office. So what happens is this VPN will create a tunnel. Tunnel means your network will only go through this tunnel. On the internet, you are not using your internet right now. Like, obviously you will require an internet to connect to the VPN, but once you connect, right, it's like there will be a private connection on the internet. It will be utilizing internet. Remember one thing, it's not like it's all private. It will be requiring internet, and this device is called firewall. Like, there are firewall devices and VPN devices. There are multiple VPN devices. So what happens is they are using VPNs, they are using internet, but the only difference is, here is like, this is your office, this is your home. What is happening is on the internet, you are creating a tunnel, a private connection, and your traffic only goes within this tunnel, right? So when you're connecting with a tunnel, this office is sharing its own IP with you. So you will see whenever you are connecting, right? After that, your IP will change. Whenever you connect to a VPN, your IP will change. So your VPN will be directly connecting or virtually connecting you to the office network or to a network anywhere in the world. So for example, you are living in Africa, right? You're living in Africa and this office is in US, right? So what happens is you are virtually connecting to this office VPN. That means your location or your IP both will change to 10.1.1.1 or whatever your IP of your office will be. And your location will show up as USA. So what VPNs are doing is they are just creating a private tunnel. They're just connecting you, let you connect through that private tunnel. So obviously you're on internet, but the problem is because you're in the private tunnel, right? Your traffic is going through that. No one will be able to read or intercept anything because these tunnels are like private. You cannot intrude. You never know whether tunnels are being created and how they're being created. That is how the VPN works. So there's a device that creates and sets up that tunnel. Yep.
So please, please, are you trying to say that if there's a VPN and there are like 15 of us connecting to that VPN, are you trying to say that if there's a VPN and there are like 15 to 20 of us, which ones connect to that VPN? Are you trying to say that all of us are going to have the same IP address?
No. See, this was an example. As I said, single device cannot have the same IP, right? Even in private also, you cannot have same IPs. So there's a range of IPs, by the way. So for example, the range is like I say 10.1.1.1. I'll be coming back to the range because it's important to understand this range, how this works. Okay. So for example, the first one will have this IP, second one can have this IP, third one will have this IP, and vice versa. Until and unless you exhaust the number of IPs you can use. You understand this part? You won't have the same IP, everyone, but you will have the same network range. You will all have this thing in common. Everyone will have 10.1.1, and this will change. There's 2, 3, 4, but everyone will be in the same range, in the office range. Yeah. And everyone will have their own tunnel. Remember, it's not like a single tunnel that you all are connecting. No. Whenever you're connecting to VPN, each individual has their own tunnel. Again, the isolation part. We don't want the traffic to be flowing from the same tunnel, because if somehow I get into this tunnel and everyone's traffic is flowing through this tunnel, right? Your tunnel is compromised, right? And remember, whenever you are connecting to a VPN and then you disconnect and then you reconnect, right? You won't use the same tunnel again. It will create a new tunnel with the new encryption keys. Is that clear? So every time you connect with a VPN, it will always create a new tunnel, always with a different encryption key. Different encryption key means the first encryption key will not work anymore. So it will always change the encryption key for security. Is that clear? This VPN thing?
Yes, sir.
So that is how the endpoint also
I'd
works.
like to ask,
Go ahead.
excuse me, I'd like to ask a question. It's an illustrative question. For example, I've had to use a VPN at some point, and every time the network was slow or acting up, I would change the, I don't know, maybe the
Region.
country, because the VPN is installed, the region, yes, the region. So what are those regions? How does it really, how is it related to the whole thing? Can you explain that to
Okay.
me, please?
There are various, you can say, concepts and things related to that. So for example, let me answer that. One second. Okay, so let me answer that. Okay, so what happens is, for example, you're living in Africa, right? You're living in Africa, and you want to connect to maybe US. For example, you want to connect to US. Okay, but the thing is, there is a difference. The difference is the distance, right? There's a distance, a large distance between you and USA, correct? The thing is, there is something called latency. So the bigger the distance, the bigger the latency will be. Okay, the more time it will take the data to like go back and forth, correct? So for example, if you want to connect to India, again the distance will be more than USA, right? Or depends. It depends on like what region you're trying to connect. And there is one more thing that is called edge devices. So it can be technical. Okay, don't get confused into that. So if you have edge devices, then the network can be like more, you can say, refined. It will work a little bit faster. But the whole point is not this. The whole point is also if you have a router. For example, I have a router, right? And you have a router. So how fast is your router? Like what kind of connection you're using? Like 10 Mbps, 100 Mbps, 1 Gbps? What is your speed? The internet speed right now? I'm asking, like, what is your current internet speed right now?
Madam, what is your internet speed?
Is there?
Is she even there?
I don't know. I'm here.
Just
I'm here. I
open
don't know.
Google and type my internet speed on Google.
You just do
Click on
speed
that.
test. It will open.
Just
For example,
yeah,
let
just,
me like
yeah,
this.
Let
Let me show you.
just do
You can
speed
do speed
test.
test. Yeah, enter, and It'll, yeah, there. See,
Speed
run
test.
speed test. You can just do that.
Yeah,
Yeah, like
speedtest.net.
this.
It will show your internet speed or your router speed.
At least it'll give you an idea like how much you're using. So mine is like 100 Mbps. So it's kind of like that.
Mine is 3.3 MB.
Okay, that's not that fast.
3.3. Yeah.
Okay.
Wow.
So the thing is, okay, let
Oh,
me
wow.
tell you, let me give you the answer. Okay. So what happens is,
Yes.
You cannot create AWS account with that kind of speed. They will flag you.
so for example, I have a router, right? Or I have a device that supports 1 Gbps, correct? You have a device with 3 Mbps, right? The thing is, it's like latency is there. Obviously, remember, latency will always be there, right? And this is, for example, USA, and this is Africa, right? You're connecting from here. Remember one thing, the speed that you're connecting to is 3 Mbps, so it will be very slow, right? First of all, your speed is very slow. Then the latency adds up, right? The latency adds up. So the problem is this will combine and make your speed more slower. Or sometimes what happens is there is a different other chance also. For example, your speed is 100 Mbps, right? And you're connecting to a device or to a network which does not have that kind of capacity. For example, this router works on 50 Mbps only. So you will request and you are able to get the data into 100 Mbps, but this router does not even support 100 Mbps. This will only have 50 Mbps. So the rate of data that will transfer to you will be in 50 Mbps only, because that is the highest it can do, right? And this data will be shared with multiple other things because there will be multiple other devices also connecting, right? So sometimes if there is a load on the router, because routers are like really fast, these VPN routers, right? So if there are like multiple devices connecting, so they take away some resources from the router, right? So sometimes if there is a lot of load on a router, your latency, your router speed, and the load on the router makes them a little bit slower. So changing the regions, because maybe that region is not being used too much, right? And that is closer to you, so the speed will increase. So these are some aspects that can affect your speed. That is the latency, the number of load on the router, and how much users are connected to that router or to that VPN region where the VPN router is. Is that clear? And your speed as well.
Yes. Yes, that's clear. Thank you.
Yes. So the faster the router you have, or the faster the internet connection you have, the faster the VPN will work as well. Okay. So where were we? Here. Okay. So VPC endpoints are like same thing. These are same thing. This is called AWS private link. Private link means AWS will set up their own VPN on their site. Like you are not the one who is setting up the VPN. They already have the private links or an endpoint. Endpoint means a fixed location or a fixed, you can say, address on which the VPN is set up, right? So when you try to connect to that address, or when you create an endpoint, right, that address will be available to you and to your resources. So when you use those, you will be creating a private connection between the resources. So it's like you will have a proxy tunnel between them. So if you have an EC2 instance and you have a endpoint, like you have a different EC2 instance in a different account, right? And you don't want to connect them via the router, or you don't want to create all those things. You can always create an endpoint, and then you can connect via this endpoint. And what AWS will do, it will create a private network. But remember one thing, always one thing, remember. So whenever you use a VPN, do you pay for it or is it free? Guys, is it free or you pay for it?
Mostly free.
VPNs.
So
Mostly free,
mostly paid.
but with limitations then, right?
Yes, with limitations.
Yes. Why the limitations? Do anyone know? Like why there are limitations on the free VPN?
I think because you have to pay for the other services
Okay,
required.
let me tell you, okay? Yes. So yeah, you have to pay. So for example, I am a VPN provider or you are a VPN provider, for example, right? So you will be buying a device that is capable of creating a VPN or handling the VPN connections, right? You will be creating a VPN router. You'll be investing into it, right? I'll buy a VPN router. I'll set up the VPN, right? This is a physical device that I'll be owning. Okay. So I'll be buying a VPN router. I'll be setting up the VPN. I'll be handling the server. I'll be maintaining the server, protecting the server, and do whatnot. Correct those things. And now, as a user, you want to use my service, right? You want to connect to US region, and you're coming from Africa, for example. You want to connect. You want to use my VPN connection to connect to the USA. So, as a user, if you are the owner, for example, you are the owner, you have put in so much money, you have put in so much resources, and you're handling that thing, as well as you are the one that is paying for the internet connection and everything, right? And you have paid for the VPN device, and these devices are not very cheap, they are really expensive, right? So why do you want to give everyone a free connection? Can you think of a reason why would I give you a free connection with the full features?
There's no reason.
There's no reason, right? You don't want anyone to use your private property without any reason, correct? Until and unless you are like selling it or you want to rent it. You will be showing them, correct? You will be showing them the house. For example, you're renting a house. You'll be showing your property. You'll be telling about your property. You will give them a short tour, right? A short tour about of the property. But unless and until they pay for the property, you won't let them in, will you? Or anyone? That's a private property, right?
Yes, sir.
You're renting it. So you won't let them access it without paying you, right? That is how the VPN works. So they are giving you a tour, a short thing that, okay, if you buy it, and obviously with restrictions, so your speed will not be good. You have very less regions to connect, maybe few regions to connect, right? But remember one thing, if you are getting something for free, like a VPN or something, never trust that. Free is not every time good, because that means your data is not that secure. Because see, I'm the one who is handling the VPN, right? I can always access the data because I have the encryption keys with me as well. So the data can be leaked very easily. That's why free VPNs or free networks are not that trustworthy. So if you're doing an office thing or something, you don't want to use a free VPN. That's why offices and companies pay for it. Is that clear?
Yes, sir.
Yeah. So remember one thing, okay? As a security engineers, you don't want to use any untrusted networks. And that is what a hacker do. So as a hacker, if I'm going to, for example, a crowded place, right? I'll just open a free Wi-Fi for everyone. You just connect to it. But that free Wi-Fi is my leverage. I can collect all your data. And that's what hackers do. Okay, I hope that is clear. So public and private subnets, same thing. Private means there will be no direct access from the internet. You cannot access that particular network from the internet. It is isolated, totally isolated. Okay, so two different networks cannot talk to each other, like two different private networks also cannot talk to each other. Okay, so and two different public networks also cannot talk to each other until and unless they have a router or something like a route connecting them. Okay, so anything, whenever I talk, whenever I say a public subnet and a private subnet, remember one phase. I have already explained. Let me create the diagram again. So whenever we are talking in VPC, whenever I say public subnet and a private subnet, okay, remember this thing. This diagram should be like coming to your mind whenever I talk about public and private subnet, so that it's easier for you to understand. So for example, I have two networks. This is my public network, right? And this is my private network. So public network means this thing has direct access to IGW. This is directly connected to IGW, like a SIM card. It does not require any router. I do not require any address translation or something. I can directly connect to the internet using the IGW, right? Internet. Okay, I can directly connect. I can directly connect to the internet. So that is what a public network is. I already have a public IP. I can directly connect. I can directly access the IGW and then connect to the internet. Private network means I don't have any means to connect because I don't have a public IP. So I am required, or I am, you can say, dependent on someone who can translate my private IP to public IP. And that is called a NAT gateway. And this is optional. Optional means if I don't have a NAT gateway, that means my network will be private. It will never have the option to connect to the internet. Even if I have a gateway, I cannot connect because I'm in the private network or my resources in the private network. Okay, so I can never have a public IP and I can never connect to the IGW if I don't have anything to directly connect. Okay, so usually private network means if I have a private network, that means I am totally isolated to like from everywhere, right? I don't have any connection to the internet until unless I'm using a NAT gateway. Okay, and public network means I'm directly connected to the internet gateway and I can access internet directly. I don't require any NAT or anything because I have public IPs that I can directly use and connect to the internet gateway. Private subnets will not have any public IPs. They cannot provision public IPs. They cannot have it. That's why they're private. And they require something, some kind of assistance to reach the internet. And that assistance is NAT, or network address translation. Is that clear? So private subnet means anything within the private subnet or anything that you create within the private subnet will never have an internet access. They cannot directly have. At least they cannot directly have the internet access. That's what it means. You can never have the internet access directly. You will require an assistance, that is a NAT, if you want to connect. But that is optional. If you don't create a NAT, then obviously your resources within the private IP will never have the public access or the internet access. And when I say public subnet, that means that subnet, whatever you create inside that subnet, will have the internet access directly because they will have the public IP. Is that clear?
Yes, sir.
Yeah. So whenever I say public subnet, that means that resource, whatever resource that is using that public subnet will have the internet access. And when I say private subnet, that means that resource or whatever resource is connected, like created inside the private subnet, will not have internet access until and unless that private subnet is connected to a NAT gateway. So if the private is not connected to a NAT gateway, they can never access the internet. But if it is created connected to a NAT gateway, then you can access the internet or the resource can access the internet. Okay. Now let me explain what is CIDR. This is the most important part that can help you to understand how the network works or how to divide the network or how many devices can have or can we have inside a network. Okay. Let me give you a very simple example. Like it's not, I'm not getting into a lot of calculations or something. Like this is what you have, but I'll just explain you in real, like easy, you can say thing. Okay. So let me create something. So for example, I have a IP like 10.1.1.1. Okay. Remember one thing, this thing is called IPv4. This IP is called IPv4. And whatever IP we are using, for example, if you see my IP right now, here, you see, there are 4 IP only, like 192.168.68.1. Always 4 numbers, always 4 numbers, 160, 192, 168, 68, 103. Always 4 numbers, right? And this is called IPv4 address. That's what is called IPv4 address because it will always have 4 brackets and 4 numbers within those brackets. Okay, so this is called IPv4. Let me clear, like write it clearly. So 10 dot maybe 1.1.1. or yeah. So remember one thing, these are 4 columns you have, right? So this is called IPv4. That's why 4, right? It is divided into 4 segments. Okay. So this first segment, the lowest value each segment can have, the lowest value is 0. This is the lowest value each segment can have, 0.0. So this is the lowest value, and the highest value is 256 or 255, because we are adding from 0. So usually the values, like total number of values, should be 256, but because we are calculating from 0, so it will be 255. So 255.255. Dot 255. So this is the maximum value a particular column can have, and this is the minimum value they can have. So remember one thing, this particular value, right? This particular value cannot go below 0, and this cannot go above 255. So this particular range can only have 0 to 255. Is that clear? This is the maximum value you can use, and the minimum value you can use. Guys, is that clear? Like, you can remember, right? So you cannot have, for example, the minimum value I can have is 0.0.0.0 in IPv4, and the maximum value I can have is 255.255.255.255. So whatever address you will see, it will never increase from 255, and it will never go down from 0. So for example, I have the IP here. Here, see, one column has 192. So this column cannot go beyond 255, and it cannot go below like 250, like 0. So 192, 168, 68, 103. See, no value is going outside from 255. It is always within the range. If you check your addresses also, for example, I check my public IP, right? Like for example, I do what's my IP? What's my IP? You'll see the same thing there. 49, 36, 169, 21. I'm not breaching that 255 value. I'm always within that value, and I'm not going like below 0. Okay. So this is the most that you can go. 255 is the highest and 0 is the lowest. Okay. That is how high IPs are built. Okay. Let me remove that again, and let me write it clearly one more time. Okay. Let me start again. So 10.1.1.1, right? So here below, like the minimum value you can go is 0, and the maximum value you can go is 255. So that means if this value goes to 255, right, I cannot go beyond that again. 255. So if this value says 255, that means I cannot change anything. It's the highest and the lowest I can go, right? These columns can hold only that much. Is that clear? Like, can anyone tell me, is that clear? This much is clear.
It's not clear to me. I'm
So,
finding it
so
difficult to understand.
For example,
This
you
I have
have
a question. I have a
go
question
ahead.
about this. I have a question about this 255. Is it a standard? Is it a standard number?
That's a fixed value.
exactly.
Okay. If it's a fixed value, I wanted to find out if it's a fixed value for
Yeah,
every IP, sub IP address that you have.
that's what I'm saying. Each
Okay.
columns cannot have less than 0 and cannot have more than 255. That is what I'm saying. And these are fixed values.
Yeah.
Within this range, you
Excuse
can
me,
have anything.
you keep saying.
Mhm.
Can I ask a question?
Sure, sure.
You keep saying that we cannot go below 0 and we cannot go above 255. Like these IP
Mhm.
addresses, I thought that they're automatic, that we just automatically have an IP address. Are we
There's
creating
nothing
the IP
automatic.
addresses?
We can
Okay.
create, but there's nothing. Never, nothing is automatic anywhere. By the way, let me tell you. What I'm trying to say is, for example, you have a box. You have a box, right? And I say you can fill in with, like, for example, you have beads, right? I can say that the minimum amount of beads you can have here is 0, right? Like For example, this box can be empty, right? But if you start filling, how much you can fill this box up to? 255, right? I'm
255.
saying that this box has the limit of 255. So after 255 beads, there will be no space to put any extra bead inside it, right? So these boxes, these are like boxes. They can change, right? But each box can only hold minimum 0 and maximum 255. So once each box have 255 value, they cannot overfill. Now you have to change and go to the other one. Then you can fill 255, then 255, then 255. That's it. Limit has reached, right? So basically what happens is this private IPs and public IPs are created or used with this thing. So whenever you are seeing an IP, the IP will never be above 255 and never be below 0. It will always be within that range. You see 192, 168, 68, 103. So no columns are breaching those values. You are always greater than 0 and less than 255. Did you get my point, what I'm trying to say? So I'm talking about each column. You cannot breach that value.
Do you understand?
I hear you, but no, I'm still not understanding. If we are creating
Okay,
IP addresses, where are we deriving them from, and why are we creating like
okay.
I don't know.
You're
It's
not
a bit
understanding the
confused.
point. It's not about creating the IP right now. I'm just telling you how much it can hold. We are not
So
on to the IP address thing right now.
do not understand the creation of the IP address. Just understand what a CIGR value is. What is the range it can take? That's what he's trying to make you guys understand. So what is CIGR? Let me just enlighten you guys a little bit. CIGR, they call it classless interdomain routing. So it means that if he's provisioning for a VPC in the cloud, that network that he wants to create, he wants to specify how many connections can that network hold? In simple terms, how many connections can a network hold? Because for each device that comes into that network will assign an IP address to that particular device or to that particular connection. I don't know if you understand.
Yes.
Yes.
So
So
Yes,
if
sir.
for
yeah,
example, right? Let
mhm,
me answer their question. For example, she's
mhm,
saying like, how do we decide what IP to take, right? By the way,
mhm,
you can take any IP. There is no, you can say restriction on that. You can have any IP, right? The only thing is, remember what I'm trying to say is you can have any IP, right? But for example, you say that, okay, I will have any IP, then I will create an IP called 256.100.500.200, right? I want this kind of IP. You can never have this kind of IP. That is what I'm trying to say. You can create any range, any value. You can create, right? But the problem is there is always a limitation to how much you can fill in each column. That is what
mhm.
I'm trying to say. So whenever you're creating an IP, the IP should be within the range of 255.255.255.255. This is the maximum. That means if you want to create an IP, you cannot go to 56.
Do you guys
You will
understand?
always be remembering like remaining within the value.
Yes.
So 254 is
No.
valid, 253 is valid,
Mhm.
right? Like this, the same thing. You can create anything, but you should always remain within this range. Then only the IP will be a valid IP. You
Do you
cannot
guys
have this range.
do you guys understand what he's trying to say? He's saying that
Yes, sir.
an IP address
It
has
cannot
four
go
blocks.
higher than
Yes, it
Yes,
can only be between 0 and 255
0 and
for
255. You
each
cannot
block.
go below 0 or above
Yes,
255.
for each block that you see in any look at any IP address in the world, for each block, you will never see an IP address that is above 255.
It's a fixed value.
It's a fixed
yes.
value. So every IP
You
address will
can
fall within that
Mm.
range for every block, for every dot. You see, it should be 3 digits dot. But within those three digits, it can never be more than everything will fall within the range of 0 to 255 dot 0 to 255 dot. So you can pick any number within those range. It will be a valid IP address. I don't know if you understand.
Yes, sir.
That much was
Yeah.
clear to me. My worry was just where are we deriving the IP address? Where are we getting the numbers from or the figures?
You're getting the numbers from when you create your VPC. Understand? You are creating a network connection, right?
Mm-hmm.
You want to
Mm-hmm.
provision for a network. It's like you going to somewhere and you build your house. That house can only contain 20 persons.
Mm-hmm.
Your company can only contain 20 devices or 20
Mm-hmm.
servers. Let me just put it in that way. So every server will have an IP address, or every connection that you create for that particular server
Oh,
will have a
okay.
particular IP that is charged. I don't know if you understand. So
Yes.
every every room you create in that particular house should be an IP address, like you are giving somebody that route or that access in your house. So you are fixing a particular range. So your CIDR is you are fixing a particular range that my house can only take 400, 500, 2,000, but a maximum will be 6,555. Like you said, 65,555 rooms can only be in that house at a time. So if my company is small, I can go for a less configuration. I can take probably 16 or 20 or 200, and that will be the maximum amount of devices that my network that I'm creating can connect to, can serve. I don't know if you understand.
Yes.
Let me explain in
Sir,
simple manner.
please.
Okay, one
I have a
second. Yeah.
question.
Uh-huh.
Go ahead.
Does it mean that does it mean that if the range it cannot go below 0 and above
No.
255? Does it mean that
Yes.
it can be in between? You can have an IP address that will
Yes.
fall even
Any
at two.
IP. Any IP.
Okay.
It's random. You can randomly use any IP. It should be just within this range. Okay. Now,
Yes, sir.
about the CIDR, like how do we decide how much devices can be within the IP, right? That is the question that you should ask. Like, for example, I create an IP. For example, this IP. I have this IP, right? How do I know how many devices I can fit into this IP? How do I know? Like, by the way, you can have billions of devices, right? But how do I know? How do I restrict that? Okay, in a particular IP, I only want 256 devices. I don't want more than that, right? So basically, this thing is decided by CIDR. That is called a CIDR, cider value, right? So CIDR is kind of like this. I'm just giving you an overview, right? But by the way, there's a calculation into it, but I'm just giving you an overview so that you can understand very easily. Okay, just remember this chart. This is the minimum and this is the maximum you can have within a column, right? Also, CIDRs are used like this. For example, you have /8, you have /16, you have /24, and then you have /32. Okay, and then there is 0, but 0 means like all. Okay, so /8 means whenever you see an IP, for example, I have an IP called 10.0.0.0/8, right? This thing tells you how much devices you can fit within an IP. Okay, so /8 means this particular column, this one. This tells you like two things, by the way. This cider value, this is the cider value. This /8 is the cider value, CIDR. Okay, this is the cider value. This tells you two things. The first thing is this will tell you how much devices you can fit in. Okay, so if I look at this thing, you see there's /16, by the way. Let me show you /8 also. So if I talk CIDR calculator, if I do this, for example, right, and I type the same thing, 10.0.0.0 /8 here, /8 here, here. These many devices you can put in. You can't even, I think, once, 10s, 100,000, 10,000, like 167 million kind of thing, right? That many devices you can put in /8. And then if you change it to /16, you see you have like from 1 to 32. Okay, so if I go to /16, where's the 16? Here, you can have 65,536 devices here, right? Like we see here. So this will tell you how much devices you can have, right? There is a whole calculator you can check. It will tell you how many devices a cider can hold. The main thing is not the devices that it can hold. The main thing is how do you and why do you need this cider value? Okay, this is the main question. Like, why do we even need a cider value, right? So cider value, the first thing is it can tell us how many devices we can add in a network.
Same.
That means, yes.
Yeah, please let them try to reason why are we making this side of values? Why should a network engineer or you that are creating a VPC, why are you positioning this side of value? Let them answer. Just give them time. Let them try to think and answer.
Okay.
That why is it important in the network to making sure that you have a network range, you create a side out range. So in your VPC, why is it important in terms of security?
Okay. Okay, you guys can try. So
Yeah,
the first thing is, as I said, that it can tell you how many number of devices you can add. But what else?
So I think a specific range would increase the level of security, but I think it's a specific range, like a range will increase the number of security, but if there's no range or if the range is too big, I think the level of security will be so.
You're correct. But
that is correct,
why?
but we need why. Why should we like Singh said, we know how many devices can connect. Why is it important as a security or as a cyber security expert or engineer? Why is it important knowing that you have an X amount of people that can connect? Why is it important? Why is it important in terms of security?
To monitor easily.
No, let me give you a hint, okay?
I was saying for easy monitoring.
No, it's still sketchy. Madam, kind of go deep.
And identify or be able to detect if there's any
recently a while ago, I gave that answer to you guys. When I was explaining the subnet, that is the hint.
Yeah, he already gave the answer when he was explaining subnets. If you guys were paying attention,
I think it's to be able to control the speed, to know the speed limit of it.
It's not so. It's not about speed.
Speed is not even the issue here. Okay, let me give you one more hint. Okay, if you have a house, as Stanley was saying, right? If you have a house, and you have multiple rooms, right? You want to have some kind of restrictions, how much you can hold, right? Or not? Like you have a house range of like 16 persons, and you don't want more than 16 to come into your house, right? Because there's no space. So why do you have that kind of restriction to your house? And why can't you fit in more?
Because you don't have enough space to contain everyone.
You don't have, but why are you even doing a space? Why not just use the whole house?
Privacy.
Privacy, yes. So basically, CIDR value is used to isolate different networks so that these devices, remember that HR department, office department, we don't want everyone to talk to each other. We want isolation so that the data that is flowing should not be accessible to each other. We want isolation. So CIDR values are created so that we can isolate different networks, we can create subnetworks, and then we can isolate those networks and devices from each other. We don't want them to talk and share the data within themselves. That is the security reason why we use CIDR values.
Have you guys I hope you guys are writing, because I'll ask it again another day.
CIDR values.
Like we want to restrict the number of devices.
Yes. What are CIDR? When it's CIDR values, CIDR values are CIDR. You have to know the full meaning of them, because when you see them in short form, you might not understand. So by the end of the class, I'll send you guys a link to the video and the slides for this video, because it's very important you guys follow up with the slides, the slides for this class. Okay.
Okay. So whenever we talk about CIDR values, right, the first thing is they will tell you how many devices can fit in, right, within that IP. The second thing that they tell you is how the network is defined. And this is the important part. Like, this is why I have created this chart. So whenever I say, for example, this particular IP has a CIDR value of /8, right? So this is /8, correct? This is where you see /8 in front of it, right? So that means this particular value cannot be changed. This is already full. Only we can change these three values. That means my IP will start from 10. Always, my IP will always start from 10. But these particular values, these three values can be changed. So it can be 0.0.0, it can be 1.0.0, it can be 1.1.1. So all those are valid, but this will never change. Never change. This particular value will never change because this is where your /8 is. So that means this tells you that this particular value is already full. So full doesn't mean it should always be 255. No. /8 will tell you that this particular IP will always be remaining same, right? 10 is always the same. And after that, whenever you have 1.0.0, for example, you have 10.2.0.0, that means the IPs are changing now. This is a different IP, this is a different IP, this is a different IP. 3.0 is a different IP. The network is changing. So for example, this is different IPs, right? But the network, this network is same, 10 dot something, right? But for example, I change this to 11.1.0.0. Now you see this particular value is changed, the first value. This is changed, right? That means the network is changed now. This is a different network than this one. For example, let me give you one more example. Okay? Now my CIDR value is not /8. For example, my CIDR value is /24, right? And my IP is 10.1.1.1, right? And this is /24, and this particular value is /24, right? So this is /24. Now what I mean is this value, and this value can never be changed. This is all full. This is all full. Only this IP can change. So my IP will be 10.1.1.2.3.4.5. This can never change. If this value change, any value, if this value, right, these values, anyone changes, that means my whole network will change. They will be isolated. They cannot talk to each other. I know this can be confusing, guys. It will require a little bit of, you can say, your concentration and your understanding. But just understand this chart means this first value will have /8, /16, /24, and /32. And whenever you define a CIDR value to IP, that means that will be static. These three things can get static. If this is /24, these three values cannot change. And if these values are changing, that means the IP will, like the network will change. So you can only change this value every time. And if I do /32, that means nothing can change because this is also full. So this is the only IP that you will have. Let me ask you guys a question, okay? So that I understand like everyone is on the same place. For example, I have an IP called 192.168.1.1. And this has a CIDR value of, sorry, let me add as well, /8, /16, /24, and /32, right? For example, I said this is the CIDR value of /16. So can anyone tell me which IPs are full and what can change here? Like what I can change and what I cannot? Anyone wants to give it a try? Okay, let
What's
me
the
explain.
question again, please?
I'm saying that this particular IP has a CIDR value of /16, right? So what can I change here? So that I don't change the network, but I can have the IPs with the same network. What values can I change and what values can I not change?
So you can change 192.
No, I cannot remember. See, okay, let me explain one more time, okay? So for example, I say /16, right? This is where 16 is, right?
Oh, yes, sir.
So anything before 16 cannot be changed. That means this value will always remain constant. This can change.
Yes,
like
sir.
this can go to 2, 3, 4. This can also go to 2, 3, 4. That means whenever we're changing this thing, the network will not change. The network will remain same. You will always be in the same network if you change these values, right? But anyhow, if this value gets changed, any values within this range get changed, that means the network will be different. You cannot talk to each other. Let me give you one more example or ask some 1 second. 11.2.3.4, for example, right? And again, /8 /16 /24 /32. This has a CIDR value of /24. So now tell me what can change and what cannot change.
So one can change. 11, 2, and 3 cannot change.
Exactly.
Yes, 11 to 3 cannot
Yes.
change.
So 2, 3, this will never change. This can change. This can go to 5, 6, 7, 8, 9. This can go. So what do I mean by change, right? The meaning of change means even if I change this value, right, the network will still remain the same. The network will still remain the same, right? But if I change this value, this was /24, right? This is /24. If I change this value, now, for example, if the value is 2.4.1, what happened? I changed this one, correct? That means now the network is totally different. This network and this network cannot talk to each other. They are different now. Do you understand the meaning of CIDR? So if you change the main CIDR value, the network will change. Are you getting my point? Let me ask one more. Now someone else can answer. 100.1.1.1, right? Again, /8 /16 /24 and /32. Let's do /8. Okay, now tell me what do I change to change the network? To change the network, now I want to change the network. What value should I change?
100.
I think you should change 100.
Yes, exactly. I think now some people are understanding. Yes. So if I change this value, the network will change. And what other values I can change so that the network will not change, but I'll remain in the same network, but the values can be changed. What values are those?
1,
1, 1, 1.
1.
Yes. Yes, I can change these 3 values and I will always remain in the same network. But now you understanding one thing. This 100 value is okay, right? But this can have 255, 255, 255, correct? So that means this /8 can hold like that many IPs. So 100.1, 100.2, 3, 4, 5, 6 here up until 255. Again 255, 255. These values can be put in like this, right? So I can have multiple IPs, okay? But still I will not change the address. So until I fill this whole thing, until my IP is like this, 100.255, 255, 255. Now can I change it? What will happen? What will I have to change if my IP is like this? This is the maximum I can go, correct?
Yes.
Now what will be my next IP? What is there to change now? Because I cannot go overboard. I cannot change anything here.
So 100.
Yes, now it will be 101 and then 0.0.0. Again, it will be 101.111, right? So this will be /8, but this is now a different IP. Do you understand now why the IP is changing? This is the highest. That's why when I put /8 here, right? Once I've filled in these 3 values, because I can change these 3 values, correct? Because this does not fall under /8, right? I can change this value without changing the network. What if I fill these things? I will have to change this. And if I change this, that means I'm changing this IP. That means this is a different network. Again, once this is 101.255.255.255, I'll have to change again. You guys understand the part, what is happening here? Okay, one last time, okay? If I do 10.0.0.0, 0.0.0, and this is /16. So what can I change here?
So I think you can change 0.0.0.
These two only, because this is /16.
Oh, yeah.
Remember this thing. That's why I'm putting this thing, so that you can remember. Right? This is /16. That means I can never change. If I change this value, my IP will change. The whole network will change. So this will be a different network. And remember, two different networks cannot talk to each other. That is the whole point. That is why we are dividing into smaller networks, so that the particular network cannot talk to a different network, because they're divided now. They're different. Right? Creating a room inside a big home. That is what it is. Okay. So if I create this, for example, if I do this thing, 0 dot, and these two can be changed, correct? And if I fill this value 255.255, now what happens? These two are filled in. I'll have to fill in this one, right? So 10 dot, if I change it to 1, then 0.0, this is a different IP, because the CIDR was /16 and I changed the value of /16 because I had no choice. I cannot fill in more than these values. Is that clear?
Yes, sir.
So that is how you know the CIDR. So /16 can hold this many devices, that is 65,536. So that means 65,536 devices will be in the same network. If you use this whole network as it is, that means all these devices will be able to talk to each other. These many devices can talk to each other because they are in the same network. And we don't want that much, right? Because these are a lot of devices, right? So what we do, we divide them into more smaller networks. We do like /24. In /24, you can have, I think, how much? 256 only. Here, you see, only 256 IPs. So basically, when we create a VPC, right, we use a big chunk and then we create multiple subnets from them. Now, let me explain one last thing. Private and public subnet, like how does that private and public subnet fit in here? How do you know something is private or public? Okay. So for example, this is my IP 10.1.1.1. Okay. And how can you tell this is private or public? Guys, anyone? Just by looking at this IP. For example, this is /16. How do I tell you? Like, how do you tell me that this IP is public or private? Just by looking at it. How do you define?
So I think because it is restricted. The
No,
private
it
is
is an
private
IP.
because
It's
it's
an IP.
restricted.
Okay. So see, the concept is same. As I said again, if this IP, right, has connection to IGW, Internet Gateway, right, then it
Okay.
will be a public IP.
Public
If this
IP.
IP is like, for example, you have a router, right? You have a router, and this router is using this CIDR because router is the one that is giving them IPs, right? Your mobile phones,
Yes.
your laptops, when you connect to a router, your IP is given to you by the router, correct?
Yes.
So router is creating the whole network. So you can give this IP to the router. Router will give you similar IPs like this. So the IP can be 10.1.2.3, 4.3, because obviously it is /16. So these two values cannot change, right? But these values can change. So router will give you something similar, right? 4.2, 4.6, whatever. It can give you random IPs. Okay. The problem is, what if the router is not connected to any internet? What will happen? Will you be able to connect to internet? Like, will you be able to go to google.com and anything if your router does not
No.
have an internet connection?
No.
Still, you have the IP. Still, you have the
Right.
IP, but you will not be able to get the connection, correct?
Yes.
So it all requires to have a gateway. So your ISPs can have the same IP. The ISPs can have the same IP, but those IPs have gateway connections to it. They are public IPs. So if an IP has a direct gateway connection, right, they become public IP. And then that public IP can be used to give you internet connections. Is that clear? So those IPs, any IP can be public if they are connected to a gateway, internet gateway. Any IP can be public IP. Okay, and any IP can be a private IP if you are not connected to any internet, or if you don't have any means to connect to the internet directly, at least directly or indirectly. Indirectly you can connect, right? But directly you cannot connect. If any IP or any network connects to IDW directly, even if you name it private, it was private, right? And I connected this particular subnet to internet gateway. Will it still be a private IP or a private subnet?
Yes, sir.
No, it will not. You're connected to IDW now. How are you private anymore?
Oh no, you're connected directly to the internet.
Right? You have internet access. So how are you private
Yes,
anymore?
you're
You're
public.
not private anymore. Right? You're public now. So, and for example, if I created a subnet, right, and it has no means to connect to internet, so you will require a translator or a proxy in between, right? That proxy is called NAT. And NAT can help you connect. But the thing is, you're still private. You are private only. You are relying on someone that has public access, right? So that does not make you public. Okay, remember this part. You have your mobile that is connected to a router. If I disconnect the router internet, will this mobile still have internet connection?
No, sir.
Right? That is the whole concept. So if this mobile has a SIM card that has data availability, it will become private. It will become public, right? Because now you can directly connect. You don't require router, right? But if I remove the public connection, if you don't have data, you'll have to rely on a router. Router will not give you public IP. Router will give you a private IP, right? You will always have a private IP. And router will use its own public IP to connect to the internet gateway. So it will have to mask your IP. Okay, that is called NAT, network address translation. You will have to rely on router for everything. And if the router is disconnected from the internet, your mobile is also disconnected from the internet because you're private. You don't have any direct connections. You don't have any means to go to the internet gateway. You never know how this works. You will have to rely on this thing. So that is what a public and private is. So if IP has a gateway connection, right, it will be a public IP. If anything that does not have any internet gateway connection and they are relying on something to connect to the internet, they will always be a private IP. Is that clear?
Yes, sir.
Yes.
I hope everyone understands this concept. I want you guys to go through this concept. This is really important because this is the same concept we'll be building our VPC. Okay, the NAT, IGW, public and private. That's it. That is what we have, and the CIDRs. I want you guys to do practice a little bit of taking on internet or something. But if you want to calculate and all, this will require a little bit of formulas and all. But remember this thing, you can use online calculators also like you have. And okay, one last thing that I want to explain. Okay, for example, if my IP, like I have an office, there's always a restriction. Okay, if I have an office, okay, and I have one more office, if I have an IP called 10.0.0.0/16, here also I'm using the same IP, 10.0.0.0/16. So until and unless they are talking to each other, like these offices are working on their own, like these are private right now. Okay, this is private, this is private. In public, you cannot have this scenario. It's not even possible in public. Okay, that's why I'm saying in private. So these offices are working fine. They have the devices. These are working fine. Correct. Now, what happens is I want these two offices to connect together now. What will happen? How do we do that? Anyone? There will be always be a router, obviously, because routers are used to connect to two different networks, right? So, how do you connect them? Or what can be the problems?
I can use the IGW.
No, I want to keep it private. I want to keep it private. I can use the router. Doesn't matter. You don't require. Like I don't want them to use internet. I just want them to talk to each other directly.
You can
You don't
use
require internet for that. So one more question. Okay. So you see these IPs. These IPs are the ones that they will be using as an address to address themselves. Correct. So here also the devices are using the same IP, because these devices are not using the names. They always use IPs. Like humans, we use names, correct? So for example,
Yeah.
Stanley, right? And my name is also Stanley, for example. And like whatever the Stanley name is, my name is the same one, correct? So if
Yeah.
you want to address, if you say Stanley, who will answer? If I ask for Stanley, who will answer? Because my name and Stanley's name is the same. Everything is same.
The
Who
both
will
of you.
answer?
Everybody,
Both
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 of
of
you.
you, right?
answer.
What
Yes.
if all the devices will have the same IPs or same kind of IPs? How will the router know who is asking and who is answering? Like where you want to go? Because the IPs are same. How will the router
Yes.
know who is answering and like who is asking for a reply and who is answering and who is questioning? It'll never know.
You
It'll get
never know.
confused, right? The IPs is conflicting right now. So always remember, whenever you're creating a private connection, right, between two subnets or the VPCs, the IP should never conflict. If you have a conflicting IP, they will never talk. It will fail. So whenever in VPC or a private network, it's always happens in the private network. In public, you will always have a unique IP. So you can never clash. Okay. Always remember, two different networks, if they have the same IP, they can never talk to each other. They will clash. So for example, if you're creating a VPC, that is 1.1.1, and this one is 10.2.0.0, or a 1.1, whatever that is, /16 and /16, right? You see this value and this value is different, right? That means these two are different IPs, and then they can talk to each other. The IP should never match. That is where the CID values comes in when creating an IP or subnet. That's how you know what kind of IP you need to create. So if I change this to 1, because this is /16, now this is a different IP. Now they can talk, because this IP will start from 10.1 always, and this value can change, right? 10.1, 3.4 or whatever, right? And this is 10.0. So this will always be 10.0.1.2, and now this is different. So the connection will happen. Router will be able to create routes between them. Is that clear? So two different two different networks or two different VPCs, right? If you want to connect them, they cannot have same IPs. They will conflict. But it's not like you cannot create. You can create in different regions. You can create same VPCs with the same IPs, until and unless you want to connect them. So the moment you want to connect them together, right, you cannot do that. There will be no connectivity. And that's how you decide. Is that clear, guys?
Yes, sir.
So until everything is private, you can create any IP. It doesn't matter. It can be any IP, any IP. There's no limitation. The only limitation is the maximum value can be 255 and the minimum value will be 0. But anything can be created. Okay. Okay. So guys, just go through it. This is really complicated because IPs are not easy to learn, right? This is kind of a networking thing. Like if I say me, right, I required at least a week of time to get an understanding properly about this thing. So it's not easy to take a grasp of. It will require a little bit of practice and understanding, right? But once you understand, it will be like really clear for you. Like you will never make mistakes when creating IPs and VPCs.
Okay.
Okay, so Stanley, you can handle their account creations, right? And then we will work on the VPC practical, like.
Yeah, I'll do that. So Friday,
Okay.
yeah.
And and tomorrow you can always ask them for any doubts or anything, and then just clear out whatever they have the doubts, and then on Friday I can continue from there.
Okay. Okay, thank you. I think that is all for today. You guys have, it has been a lot of technical explanations today, so you guys need time to unpack. So we won't say much today. So I'll just let you guys let it simmer in your heads. Tomorrow I will try to call you individually to see how you can get your cloud accounts, and so that you'll be practicing. You start practicing
Yeah.
maybe tomorrow or Friday or for the class. to do something with their account. Please, you guys make time for those.
This one is
Those who are in
tough.
Cameroon.
Yeah,
If you can
this will
mute
be.
yourself, just
Yeah,
mute you.
this is supposed to be tough, but once you understand,
Yes.
you will never forget.
So please, you guys should try to watch the video and try to practice. The concepts are the same and they're not difficult. If you go through them they are the same things, the same idea you learn public and private networks. You take that same idea to public and private subnets. It's the same concept. Nothing changes.
Yes.
So you guys just please try to practice, try to watch the videos. Then I'll call you guys tomorrow individually so that create those accounts on AWS so that you can practice. Friday will be hands-on. You guys will see how all these things have been provisioned. Everything you've learned today, you see how it will be used practically so that you can have that hands-on knowledge. So I will make sure that you guys have your account so you can practice because we'll be provisioning from EC2 instances right up to VPCs. So you guys should be aware and how to know how to follow on what thing is doing too. So try to practice, try to watch the videos. Come with questions next time.
Yeah, and just note down on your books and copies anywhere, and then you can practice, and then you can come back if you have any doubts.
Okay. So you guys have a good day, and we'll meet on Friday. I'll call you guys tomorrow and talk. So bye bye.